Yeah, I think as far as human travel goes, and really any space travel, I think that we really do need a revolution in propulsion. If we are ever going to actually become an interplanetary species, like thinking further in the future, but even in the near term, we could accomplish so much more if we could revolutionize our propulsion system.
And a massive transformative purpose is what you're telling the world. It's like, this is who I am, this is what I'm going to do, this is the dent I'm going to make in the universe. Now, we have went out to Twitter, to the community there to ask for questions. We have an incredible list of questions. Some of these are great, and I want to just take a second and share them with you because I think they're worth answering. So, and feel free to say, not my area, or I'll answer it in a few years. But Dan asked, I would love Amber's thoughts on the hypothetical existence of wormholes. So,
yeah.
Do you want to go there?
It's theory, but it's good physics, right? I think theoretically, yeah.
I mean, I've seen this on Star Trek, so it's got to be.
Yeah, exactly. It's got to be true, right? So yeah, I think hypothetically, theoretically, yes, it's possible from a physics standpoint. Can we use it as humans to travel across space, right? That's the big question, the big underlying question. And not right now. Maybe later. I like to take an expansive view of what we're going to be able to accomplish in the future of humanity, because we've been able to do so much already.
Yeah, I would never say never if it's within the realm of physics.
Exactly. Yeah, I agree. So someday will we be able to use wormholes to travel? I would say, yeah, I hope so.
Yeah. All right. I'll take that. Thinks Magic Cube 7 says, how confident are you or your colleagues that there'll be boots on the moon by 2030?
By 2030. Well, I can't speak for my colleagues, but for me, I think it's so hard to tell. But I think it's going to happen. Obviously, we had a really good Artemis test last year, so that's exciting. What Starship is doing, I think, is also super, super incredible and exciting. So I think the technology is there.
And by the way, it could be Chinese boots on the moon too.
It could. It absolutely could. China's space program is growing faster than anywhere else in the world. So yeah, it could be. I think it's likely, actually.
Yeah, I would give it 90% chance. I mean, unless something catastrophic happens, I think a race to the moon surface by 2030 is a very realistic target. So I'll take bets on that online. We'll go there. All right, Amber. So another question here is, what item do you think would be the most interesting thing to send to space? That would intrigue the world. Do you have anything in the back of your mind that?
Well, you know what? I think Carl Sagan had a pretty good idea with the golden record, right? I mean,
yes,
I think
that was great. That was a stroke of genius.
Yeah.
Describe what that golden record was and where it flew, on which flight.
Yeah. So this is it's a golden record. It's an object that contains data about the human species that was sent out by Voyager, and it was almost a last minute kind of like, oh, there's this satellite going up to space. We should do something about humanity with it, and it contains like images of what the human body looks like. It has, I think, songs of like whale noises. It has music. It has
greetings from like every nation on the planet. Yeah.
So it's yeah.
It has that famous photo of a naked man and woman and the 9 planets and binary. It's amazing.
It's beautiful and it's so hopeful. I mean, that's what I love about it. And again, getting to more of the the touchy-feely aspects of space.
Yeah, the human connection.
It's hopeful, that was a very hopeful thing to do, to send that and to think there's someone out there that might see this.
Yeah, and it created an entire Star Trek movie episode. That's incredible. Future. All right, so Surinder says, I am an Indian and want to enter the domain of planetary science. What are the recent research areas so I can get ahead of the domain? I'm doing my engineering undergraduate. So if someone wants to dive in, where would you direct them to focus?
So planetary science is super interesting. There's so much going on at NASA in particular with planetary science. So we are going to soon bring samples back from Mars. So that's very interesting. So I think there's a lot of options in planetary science. Sending probes to Europa. All the planetary missions that we have planned are absolutely incredible. I would say in general, if this listener is interested in planets outside of our solar system, that the field of exoplanet science is really is one of the sort of hottest fields in astronomy right now. And so, if I was 20 years younger, I might go into exoplanet science myself.
Well, the other conversation we have a lot on this podcast is around longevity. So you'll have your second, third, and fourth career coming up soon.
There we go.
And honestly, I agree with you. I mean, that's like one of the most exciting ideas I could think about is exoplanet conversation. Another question comes up. How fast, let's say speed of light being the fastest, could we safely go is a question. And that brings us up into sort of propulsion systems and, traditional propulsion systems where we carry all the fuel from the surface of the Earth and we burn it to get speed and we burn it to slow down is kind of limiting right now. But there's a lot of conversation that I've seen on nuclear propulsion and solar sails. What are you hearing from your exoplanet friends or your propulsion friends out there about traveling to Mars or to the outer moons of Saturn and Jupiter?
Yeah, I think as far as human travel goes, and really any space travel, I think that we really do need a revolution in propulsion. If we are ever going to actually become an interplanetary species, like thinking further in the future, but even in the near term, we could accomplish so much more if we could revolutionize our propulsion system. So yeah, I think nuclear propulsion, like you said, solar propulsion, solar sail kind of technology, still pretty early, I think, in technological development, but super interesting. So I think we need all cards on the table in terms of figuring out the best ways to get our spacecraft and ourselves out into space in the future.
I'm still holding out for wormholes, though. We're going to go back to that.
Yep. That's the hopeful approach.
Nearer to Earth, space debris. I don't think people realize what a challenge that could potentially, provide to humans getting off the planet. Any conversations that you're hearing on space debris? We're seeing more and more of it, right? As more satellites get launched and those satellites bump into each other or spent fuel tanks explode. What's the buzz there?
Yeah, so I'm not in a lot of the sort of NASA conversations about space debris, other than when it does impact our satellites, which it does, right? We have to maneuver the International Space Station to avoid big chunks of debris. We have to maneuver our satellites to avoid debris. So it does, it's not a future thing. It's happening now. It's impacting space now. And so I do think that we have to figure out how to manage it. And I certainly don't have those answers, but I know very smart people are working on it.
Yeah, and I think, we're working right now on a space debris XPrize. There will be a business in terms of that. And, the solution there is falls in different categories. One solution is, can you in fact build spacecraft that go and gather the largest piece of space debris, bring them down? I remember when I was a kid, there was a television show. I forget the name where the basis was. It was a company that would go and salvage. I think it was like Salvage One was the name of it. You go and salvage debris from from orbit. The energy of that's crazy. Another idea is using space-based lasers to sort of zap the space debris in a way that slows them down. Let's talk about one of my favorite subjects, asteroids. Asteroids are of incredible interest as a future resource base for liquid oxygen, principally, hydrogen, potentially, nickel, iron, platinum group metals. But the thing that's interesting more than that is the concern of near-Earth asteroids that get too close. We just saw recently, I guess it was a school bus-sized asteroid that came within the geostationary orbit of Earth. It's pretty large. And the thing that was scary about it was discovered like 4 days earlier. I guess it was approaching from the sun. Like, we can see the asteroids that are coming from the outer solar system because they're illuminated from far away. But if they're coming directly from the sun, you can't see them. Is that a conversation going on inside the halls of NASA?
Oh, for sure. Yeah. And I think, it's being taken, even more seriously now than it was, say, 10 years ago. And of course, we just had the DART mission, successful mission.
Yeah. Describe the DART mission, because that was a super cool mission.
So we slammed a spacecraft into a little tiny asteroid, and it was amazing. And it's the first time
it wasn't just for fun, right?
Right. So the acronyms basically stands for, well, I'm going to be honest, I don't remember the first two words, but it was a redirect mission. So it was seeing if we could smash something into an asteroid to alter its trajectory enough that would be, sufficient to protect us in the future from an asteroid impact. And it worked. I mean, it was incredible. And it's the first time I've ever seen, a crowd full of scientists, a room full of scientists, react with joy when their camera stopped working, right? Because it smashed in, and then it's like, it's gone.
You see static and snow.
Yeah.
No, I mean, it was, but what was amazing was the precision.
Exactly.
With which, a bullet hitting a bullet type of velocities and smack into the center as predicted. I didn't see the final results of it because, of course, the world just tuned in for that, that moment of impact. But statistically, it deviated the asteroid in a predictable way that would be enough, with enough advance notice, to get it out of the path of Earth. Is that correct?
In general, yes. Of course, again, with these kind of things, it's all about orbital mechanics and math, right? Because it all depends on how close it is, how soon you detect it, how fast it's moving, and how big it is. Those things come into play. This was just a very sort of initial first proving we could do it. But yeah, it's incredibly important, important work. And again, I try to stay hopeful. So I would think that if we did discover something, we would have the tools and the know-how to be able to deflect a planet-destroying asteroid.
Yeah, we got to figure it out before Bruce Willis, departs.
Exactly.
So, all right, let's go back to space telescopes here. What's on the drawing board next? I mean, we have, I think they're called the Great Telescopes, right? These telescopes that we've been producing. And so James Webb telescopes, conceived of in 96, 25 years later, it gets launched. After, you said, congressional cancellation and lots of, budget overruns and time overruns and such, but it makes it, thank you to you and your fellow scientists and those who support it, because it's like, once it's there, it's like, oh my God, this is a human treasure. Where are we going next? What's the vision for, next generation?
So right now, we are building and are very far along on our next quote unquote flagship, our next big astronomy telescope at NASA. And that's the Nancy Grace Roman telescope. That's going to be launched in 2027, so not too far away. It is smaller in terms of like scale. It's about a Hubble-sized telescope, but the primary...
Just a Hubble-sized telescope.
Just a Hubble, But the big deal about the Roman telescope is that it has a huge field of view. So whereas Hubble, again, and JWST sort of stare at one teeny tiny piece of sky, sort of like looking through a straw very deeply, the Roman will be able to see large swaths of the sky, and that just allows you to do different science. So we'll have to do another podcast on the science of the Roman telescope, but it's awesome. So it's going to focus on also on exoplanets, but also on dark energy, this big, space mystery that we have of what is most of the universe made of. So Roman is, again, it's doing great. Technology is there. It's being built. It's being tested. Launches in 2027. As far as the next big thing after the Roman telescope,
bigger is better.
Bigger is better. And let me tell you what, the next big one is going to be awesome.
Okay.
So, and just to give a little background context, every 10 years, astronomers get together and say, what are our biggest astronomy questions? What do we need to build to answer them? And those are the decadal surveys. So your listeners have probably heard of these. So for the last, 2020 decadal survey, we decided that we need to build basically a fleet. So we need 3 new observatories, new big, bold, awesome observatories. And the first of these is going to be called the Habitable Worlds Observatory. So that's exactly what it sounds like. We are going to build a telescope to find life. So that is the next big goal in astronomy of NASA. So it's essentially going to search 100 nearby star systems to search for Earth-like planets. That's the goal, and to find evidence of life on those planets. So that's a big goal, but I think we can do it.
So going back to Surinder's question of what should he study, it's going to be perfect for you. Just looking for exoplanets with life.
With life.
Yeah. And what's interesting, right? Hopefully, fingers crossed, we will expand the envelope of what we can deliver to space with the advent of Starship, which is huge.
Absolutely. Yeah. And our having these big, reliable, and in this case, reusable rockets, I think is going to be a complete game changer for astronomy. And also the prospect of in-space servicing. Super important. We've done that with Hubble, but all of our other telescopes have not been built to be serviceable, including JWST. But our next fleet of observatories that we're thinking about, those have to be serviceable. And so that's something that we're sort of actively planning for. And, I think again, JWST, it's awesome. It's so worth it, but it was so hard. And, this next fleet of observatories we're thinking about it's not a whole new, it's not a revolution, it's going to be building on the technologies and the lessons learned we have from JWST to be able to build these. So this Habitable Worlds Observatory is the first one we're prioritizing. And then we also want to build a huge X-ray telescope and a huge far infrared telescope, which sort of, basically help us to get at all of those fundamental questions that we have in astronomy.
Right.
So it's super exciting. And if we can do it, I say if, we can do it. We just need the will to do it. And we need people to get behind it, to decide to do it. It's going to be hard. But I think the faster we can get these observatories in space, the better it's going to be overall. So
I can't imagine what could be more exciting. And, luckily, a few of the wealthiest people on the planet are space cadets, along with you and me. And so if government has difficulty, maybe we'll get some privately funded, mega space telescopes out there as well. I mean, what's $10 billion between friends? That's not too bad. I'm going to close us out with a question I ask my guests. So, Amber, you know about the XPrize. You know that we run these large-scale global competitions. And I'm always looking for great moonshots, great XPrize ideas. So if I were to say to you, Amber, we're going to fund the Amber Straughn XPrize. It's fully funded. I just need you to tell me, what do you want scientists and engineers around the world focusing on? Is there a grand challenge that you think would be a great XPrize? I know I'm putting you on the spot here, but I know you're brilliant too as well. So we've covered a lot of different subjects. What are your thoughts? What do you think, unleashing global creativity on might give us some interesting breakthroughs?
Well, when I think about problems facing us humans, my mind goes to climate change, of course. I think that's a huge one. And I know XPRIZE is funding things to address that. Yeah, so I think climate change is the thing that comes to mind. I think it is not only in the future, but now. It's a big problem now. It's affecting people now.
In the climate change and the space area, an idea I've kicked back and forth, and I'm curious of your view on this, is the idea of a sunshade. Can we put up a large-scale structure that would titrate, would maybe block, a fraction of 1% of the sun in a way that would fail safe and allow you to put like a thermostat on the solar flux hitting the Earth?
That's super interesting.
Yeah.
I don't know. I need to think about that a little bit. That's interesting. Yeah. Well, you've heard me say a couple of times now, I try to take a hopeful outlook on things, and I really do. A lot of times when I think about these big problems, I feel like a lot of our problems are, to address the problems, it's social or political problems rather than technological. So that's a tough side of these sorts of things.
XPRIZE did work more when you're building a technology. I've thought about just to enter this sort of conversation with you. Would an XPRIZE to look for Earth approaching asteroids from within the orbit of Venus potentially? Could we create small telescopes that would be launched and funded to look for those asteroids and give us a little more advanced warning? Maybe something like that. I wonder if data prizes, looking at all of the James Webb Telescope, like competitions to discover the most interesting breakthrough by citizen scientists, does something like that exist?
As far as prizes, I'm not sure. But yeah, there are huge platforms for citizen science, and they're fairly active. But competition always spurs on human beings. So having a competition for diving into that data does sound really interesting. So, and we have tons of data. It's great. But once we do bring on the Roman telescope, and also a ground-based telescope called the Rubin telescope, these two
Where's that one going to be?
That one, oh no, I'm forgetting off the top of my head where it's being built. I should know that. So, but it's a huge, and it's the same idea as Roman in terms of science.
Wide field.
Yeah. Wide field. And what that means is so much data that we actually don't really know how to handle it yet in terms of analysis. That's one of the reasons there's a lot of effort on machine learning algorithms in astronomy right now. So once we get in the era of Roman and Rubin data, we are definitely going to need help from humans, from competitions, from machines to be able to analyze this massive amount of data.
Amazing. Ladies and gentlemen, Dr. Amber Straughn, this was probably one of my favorite conversations. You sort of tickled the young 9-year-old in me who got, sort of turned on with Star Trek and Apollo. And it's extraordinary that the human race, using these tools, can discover everything that's going on in this universe. It's literally awe-striking to our souls. Amber, I thank you. You're going to be joining us at Abundance 360 this year on stage. I hope you'll bring with you some of your favorite images and tell some of your favorite stories, because this very much is a visual story. Anyway, thank you for painting the pictures with your words and taking the time today. Folks who want to dive in deeper, see some of these images, learn about more, where would you direct them? What website?
So to learn more about JWST and find all the images and all the great stuff, it would be jwst.nasa.gov.
Nice. Well, thank you to NASA, to Congress for putting the money back up, to all the astronomers who have been working around the clock for this, and thank you to you, Amber. It's just amazing to call you a friend, and thanks.
Thank you so much for having me.